Hello, and thank you everyone for joining today's masterclass. I see that we already have a few people on, and I know that people are joining in the first few minutes. So thanks for everybody for being on. I appreciate that. Thanks to both of our speakers for being with us today. They're going to introduce themselves very very shortly. As you know, today we're going to talk about how eBPF is really changing the way we do observability and transforming it completely. As some of you may know, eBPF is kind of the rising buzzword in observability, even though it's been actually used for quite some time for security purposes. But you can see more and more that industry analysts are covering eBPF for observability, which is always a good sign for a technology rising or gaining traction. In fact, in their hype cycle for monitoring and observability, Gartner puts eBPF in a category of technologies that they define as innovations with over enthusiasm and unrealistic projections, or technologies that they put in their peak of inflated expectations. Which I'm really interested to see or to hear what both of you think of that, but we'll come back to that a little bit later. So today we're going to skip the definitions and historical developments in eBPF because I think that these are things that anyone can read on ebpf.io or other sites. Today we want to focus on the experiences of two of our experts or two experts that are on with us today. And how it impacted, their company, their products, and what they think that eBPF will do to observability now and in the future as well. So we'll talk about pros and cons. Also, we're going to talk about practical use cases, and I really think that we do have two of the best people to discuss eBPF for observability. So our first speaker today is Bill Mulligan. Bill, you've been at the heart of the Cilium community for Isovalent for the last couple of years. I know that Isovalent offer eBPF-based networking, security, and observability solutions. And I know that you never miss an opportunity to advocate for eBPF and push for more people to use it. So thanks for being part of this one too. Maybe we'll start with you introducing yourself, Bill.
Yeah, thanks for having me. And that was a very nice introduction. So, yeah, I work at Isovalent. Our main focus is around the Cilium project, which I'm a maintainer of, which also includes the sub-project Hubble and Tetragon too. And really, since Isovalent's founding, we were focused on building the next generation of cloud-native infrastructure powered by eBPF. So, I think in the last 7 years since the company's founding, and now since it's been acquired by Cisco, that has only, I think, really proven true to be true in the industry, and I'm excited for the future of eBPF going forwards too.
Amazing. So again, thanks for being on, Bill. Shahar, you've been in the industry for a while as well, and together with Chaz, your co-founder, you were very early to adopt eBPF and identify its potential for observability before pretty much anyone had even heard of it. So together you founded groundcover, which offers an observability platform that has eBPF at the core of its proprietary sensor. Maybe give a few words about yourself and about groundcover.
Yeah, so I'm Shahar. I'm the co-founder and CEO of groundcover. Groundcover has been founded in 2021. Basically, back then, meeting Bill back then maybe would have helped me figure out that I'm making the right decision, but there weren't too many things to lean on back then. It was a bit early, like maybe a year earlier than when it kind of exploded. But groundcover took a wild bet on making eBPF usable all the way through for an observability sensor. So basically, what we're building is a full observability platform, full stack observability platform, from log management to infrastructure monitoring, all the way to application performance monitoring on API or APM. Leaning on eBPF as the main sensor or technology that collects and basically allows us to access this data in a very interesting new way. So that's us in a sentence.
Perfect. And I know we're going to talk about both of the company's products and expertise as we move along this masterclass. So before we move on to the first question, I do want to remind everybody who's online that we do have a Q&A that you can send questions throughout the session. You don't have to wait for the end for this. and we'll try to get to these questions at the end of it. You can also send questions anonymously, by the way, if you choose to do that. So just feel free to ask any question, whether it's in the Q&A or in the chat. You can use the chat to know where you're from. That's actually always nice to see, and I see that some people are already doing that. So let's kick us off with the first question to both of you, and whoever from you wants to answer first is welcome to do it. So I'm wondering, how are you using eBPF observability in your current product? And why did you choose eBPF over all other available options to use in your product?
Billy,
Cool.
want to
Shahar,
take it? Cilium wins in being more veteran than groundcover. So you take it first.
Okay, sure. Yeah. So Cilium was founded on eBPF from the beginning. And the reason why that is actually the co-founder of eBPF actually works at Isovalent. His name's Daniel Borkman, super nice guy. And he was together with a couple other people, and they decided to found the Cilium project. And the initial idea was to do eBPF-based networking. Right. And so they're building out container networking for the cloud native era. And one of the first things that they realize is, as you're running clusters of containers, one thing that you need to really have is observability. Is the network actually working? Right? In the world of distributed computing, everything's going on the network. And so you need to be able to understand if the network is working or not. And so that's where the Hubble project came from. And what Hubble provides is network observability. And the way that it does that is it takes the information from Cilium, which is the CNI in your Kubernetes cluster, and pulls all that information. You can then kind of either like view it through Hubble logs, or you can visualize it through the Hubble UI, which gives you kind of like a graphical interface of all the different network flows within your cluster. And so that's kind of like the network observability part. And then I think 2 years ago now, Isovalent also open sourced Tetragon, which is the security observability part of the Cilium project. And what Tetragon does is, since eBPF allows you to see anything that's going on within the kernel, it allows you to also understand when there's malicious actors in the kernel too. And so Tetragon allows you to monitor for malicious actors or events, and then either alert on those or do runtime enforcement too. So I think the power of eBPF is that it has complete visibility of everything that's going on in the kernel. And so that's why we chose it for observability within the Cilium project. And like I think our specific use cases are tied into kind of what the project was founded on. First, like the network observability aspect with Hubble, and then later on the security observability part with Tetragon. Since Isovalent was kind of started with some of the co-creators of eBPF, there wasn't really any other options to consider. That was kind of what they bet the company on since the beginning.
Yeah, that makes sense.
Yeah, I mean, on our end, it's a bit different in a sense that groundcover is walking in like open eye to a very mature market, basically the observability market or the APM market. Has been around for like 15 years, filled with public companies. It's one of these mission critical products that every company has at some form or another. It's not something that is considered luxury. Everyone has log management, infrastructure monitoring, tracing at some point to figure out what they're doing. And going into that, is insanity, like by definition. But I think that part of what happened to this market is part of the reason that we're choosing eBPF and going all the way through to that is that eventually there's not been too much innovation in this market for a while. And part of the reason is that reinventing the way the data has been collected is not something that moves as rapidly as the application itself or the products or their offerings. And there has been mostly developments in the side of how can I present data better, how can I allow you to query it better, and so on. And maybe the most significant innovation in like the past decade was OpenTelemetry, of saying, let's standardize the way we collect the data and make sure that this is at least democratized and not owned by a vendor, and that everybody owns their data and is collected by one standard. But this was also not a significant innovation. And eBPF suddenly provides a step function into what you can do for observability. And that's the reason maybe to try and reinvent the entire cycle right now, and not wait for another decade. I think that's kind of happening all around security and networking, as you mentioned. But that's why groundcover chose eBPF. It allows us to reinvent the entire observability stack, from collecting the data very differently all the way through to processing it distributedly within the client's environment and then storing it differently. And choosing eBPF, just like Bill says, has kind of a magical attribute to the way you onboard into the system. People are used to observability platforms being built into tiers. You have log collectors, you have infrastructure agents, you have an SDK in your code. Data flows in from different tiers. You pay separately for the different tiers, but you also use different technologies to collect all these data verticals. And suddenly, eBPF allows us to create like one sensor out of band from the application that can kind of pull all this data in at once. So that is a significantly different approach to how you onboard into a system. You can install Cilium or install groundcover in a minute, and basically, get all this data flowing into your system, where before you had to work months and weeks to kind of get that in place. And it also provides a very tight coverage. Something about eBPF, and Bill, you mentioned it in regards to Tetragon and Hubble. There's something very just about it, right? I mean, it doesn't care what piece of code it's monitoring. It doesn't care if you put in the work of instrumenting an SDK or pick and choose whatever to monitor. It's going to be monitored regardless of your intent or will. Human errors or human decisions or human hard work suddenly gets out of the equation, and that provides something that observability really needs, which is a tight coverage, a uniform coverage, practically an independent coverage of the different teams and what they have been doing to get observability. So that's a lot of the reason why we chose this technology as kind of the engine behind groundcover.
Cool. And I think some of you touched on it in your answers already. But has your use of eBPF evolved over time, and what are some key milestones in the development of eBPF within the observability domain? Maybe you take this one, Bill.
Yeah, this is a bit of a funny question for us at Cilium, because in some ways, Cilium and eBPF kind of co-evolved at the same time. eBPF was something that was very new in the Linux kernel and was looking for actual production use cases, and the Cilium project was one of the first use cases for eBPF. And so a lot of the features and functionalities coming to eBPF in the early days were based on the experience of running Cilium in actual like networking or customer environments. And so they've kind of grown together, which has been, I think, probably like quite a cool like process to watch. And I guess some of the key milestones in the development, I guess for us, it was just really adding the observability sub-projects. And I think this is one of the areas that I think eBPF really shines. I think Shahar was talking about that earlier, right? Is that you don't have to worry about what you're trying to instrument. Like eBPF can see all of it. You don't have to make any code changes. It's really this ease and simplicity of use to provide a much better experience, is I think why a lot of people are turning to eBPF for observability right now.
Yeah, I think that same for us, in a sense that eBPF is kind of moving in a very clear vector for the last few years, but it has made some leaps that eventually, with every new turn in the last few years, it allows us to basically depend on heavy production grade use cases on this technology. So if before, a few years back, it was kind of experimentary to do tracing on top of eBPF, you might not want to do it in high scale. Even the data models between user space and kernel space perhaps weren't ready for that all the way through to pass all this data and use eBPF for not just filtering and decision making, but also to truck huge volumes of data from kernel space to user space because you're doing Kafka Redis observability, right? So I think that has significantly evolved in the last few years, and it allows us, and also I think the market, kind of as it goes forward, to basically build any observability use case on top of that almost entirely, and make sure that we can trust this technology to be more than probing into looking into a straw into what happens in the kernel, but actually depending on it fully to analyze data at high scales, do networking at high scales, analyze security events at high scales, and things that perhaps were a bit edgy or new.
Cool. So let's talk about some of the pros and cons, or let's say the strong points or limitations of eBPF. And we already have a question from Gilad here in the Q&A that's already addressing or touching on that a little bit. He's asking about what the performance impact is for using eBPF. But let's try to just take a step back and just talk about the key advantages in general. And I'm sure you're going to touch on that as well. What are the key advantages of using eBPF for observability, especially in terms of complete visibility and low overhead? Maybe we start this time with you, Shahar.
Yeah, so I think that clearly we talked about coverage and all the general words, but I think that the main advantage eventually breaks down to humans in the process, because you can claim that you don't need an eBPF sensor to collect data for observability. SDK instrumentations, OpenTelemetry, or other vendor-based SDKs have been around for a while. Put in the hard work, instrument. In most cases, maybe it's half automatic, and you'll get there, right? You'll get the intimate data you need. But I think that this is exactly where eBPF, kind of where technology and humans in the process kind of combine. I think it's been emphasized specifically in cloud native environments like Kubernetes. So if before you had like one Java server running one process, and that's it, maybe a Java engine would figure it out, and maybe for that specific environment, eBPF does nothing but being cool. But as you move to microservices, as you evolve into these modern environments where you have 15 different teams running in 15 different languages, running 100 different microservices in production, then suddenly being on one kernel that runs all these 150 containers and seeing everything from there without talking to all these people, right? That has to instrument their code and coordinating all these people to do that equally and at the same depth. This is a major advantage of eBPF for observability or for any other purpose. And I think that's why for Kubernetes environment, for high scale microservices environment, that's why it's so powerful to install a sensor and just see all this data. So even if you could have gotten this data, and some data from eBPF is still very unique and unreachable by SDKs, but even if you could have gotten all this data, I think one of the pros is that cycles are cut short. One person that is responsible for getting the data, like being the DevOps or the SRE, can suddenly pull it off by installing one sensor, and that's it, and you're covered with one uniform aspect of the system. So I think that's a major pro to kind of mention, and maybe a surprising one, not relevant to technology so much.
Yeah, and I think to add on that a little bit, I think you did a really good job covering of eBPF provides this great coverage of all the things you do know, but also what about all the things that you don't know, right? A really hot topic right now in software in general is security. How do we make sure that our systems are secure? We don't have bad actors intruding our system, right? And if you instrument all of your code that your developers are putting into the system, okay, great. You are tracking everything that you know, but what about what you don't know? And that's exactly what Tetragon provides with eBPF is, right, since you're running this single kernel and you can watch everything that's happening in the kernel, you're not trying to instrument, right, individual applications. You're instrumenting like the whole kernel at once. And so you can track everything that's going on. So it really is providing you complete observability over your whole system. So whether it's, one application team forgets to instrument their code, or there's a bad actor, like infiltrating into your system, eBPF can see all of that, and that's a massive advantage. Do it once and you get the benefit the whole time.
Cool. So let's stay with you, Bill, for a minute and talk about the flip side of that, and let's talk about the potential challenges and limitations of implementing eBPF for observability. Can you share some of your thoughts on that?
Yeah, definitely. And I think that goes a little bit into the performance question that we had before, right? So eBPF is really great. It can provides you all of this information, but all that information can be overwhelming, especially, and it can have an impact on your system. Uh, like some of the challenges with eBPF is being able to effectively filter through all of that information. Also, understanding what information you need to collect, right? If you can see anything, the real question is, what do you need to see? And so eBPF has a lot of benefits, but you need to think about how you're going to do it. Otherwise, you're not going to have any benefit actually out of it. And so going to the performance question, it's like, it really depends on how you leverage and use eBPF. I think people think of it as like this single technology, but it really it's a lot of little programs running in your kernel, right? And so the question is, how many programs are you running? How often are they being used? And if you're trying to instrument everything and check everything all the time, obviously that's going to have a high performance impact. If you're only looking for really critical events and only looking for very, very specific instances, that's going to have a low performance impact. However, I think an important thing to note about on the performance side is that eBPF is running in the kernel almost as fast as natively compiled kernel code. So you're already getting a huge performance boost out of anything running in user space too.
Yeah, I mean, to add on that, I would just say that I mean, totally agree with Bill that eventually it breaks down to what you will do with eBPF, and I think we're still in the honeymoon phase of eBPF is open source, so it makes sense for everybody to be interested in how it operates. But eventually, it's a very complex technology under the hood, and building things like Hubble or groundcover or whatever it's going to be on top of these these are very complicated sensors really on top of eBPF that were built to withstand scale, that were built to use the technology in a proper way. So not every ad hoc eBPF program would kind of fit your needs if you're talking about actual production grade needs. But I would say that eBPF has a few very different, very interesting kind of issues or advantages regarding to performance. One of them is that eventually, first of all, it's very transparent, right? I think that people don't fully understand specifically in observability. We gotten used to not being able to measure that, right? I'm instrumenting a New Relic SDK in my code. How much that degrade my performance? I don't know. I have to A/B test. I have to rip it out of my code. Who does that, right? And on the other hand, figuring out how much resource it's going to take, that's also not easy to measure. And it's practically being spread out in any instance of my application, right? So if I'm talking about a microservices application, it might be even a low performance overhead, right? But it's running on every piece of instance of my application, and it can be distributed in Kubernetes into 100 different containers running that piece of code that tries to monitor my application. eBPF also provides the ability to run centrally in one place, which in Kubernetes, for example, that's a major advantage because you're running in one Linux kernel, right? That serves hundreds of containers sometimes at the same time. So that's very efficient. For example, in Cilium, it will break down to the comparison sometimes between a sidecar and Cilium, right? Between running something in each and every pod in your production compared to running something in a central place. And that can be dramatic. And it can also be transparent. You know what you're running, you know how to measure it, you know where it's running. It's not running intricately in your code where you can't kind of break things apart between your application and the application monitoring your application, which is clearly something you don't want to monitor, right? So that is something that performance-wise eBPF does bring to the table in a very nice way compared to what we have today.
Cool. So I want to touch on a question that we have in the Q&A as well, and invite more people to continue asking those great questions because I don't want to leave everything to the end. But we do have a question about how do you debug your eBPF codes for bugs, or how do you debug your eBPF codes? I don't know if...
Yeah, I see it also relates to another question about how do we separate data.
Exactly, yeah. How do you troubleshoot the out-of-band network that transfer the eBPF sensor metrics?
I would say one thing that, first of all, I mean, debugging eBPF is not super easy, but I think we can trust the community to kind of improve that over time and make these tools more and more accessible. But as I said before, I think that eBPF should be open source and should be accessible to everyone. But I think that over time, the feature richness of eBPF won't allow everybody to kind of reach the same level with working with this technology. But I mean, you should definitely try it out and figure out if you want to dive deep into that. Regarding how you kind of handle and separate the data, the question was, how do you make sure that people can see who needs to see the data? I assume that's the question, because you're running in the kernel. And I think it's a good question, but it's not very different than any other collection method, right? Even if you're running a Java agent or running an agent in your machine, eventually it collects information that you don't want everybody to have. And there's another piece running in the user space, in this case, some application in the user space communicating with that eBPF program, kind of provisioning the process. It's not just flowing data out there to space and everybody can access it. There's some other entity that is provisioned by role-based access and everything that requires the segregation between different users accessing this data, which is clearly intimate in some cases, like traces and security events, so on. Bill, anything from Tetragon that you can think of here?
No, I think you covered most of it. You don't want to. It's the same way. You're collecting information. You don't want to show it to everyone, so you need to implement some type of RBAC either in your product or in your system, and it's up to you whether you're relying on a vendor or a homegrown solution.
So, Bill, let's stay with you for a minute and go to considerations that observability teams should take into account. So, what should they take into account when they are integrating eBPF with in their existing tool chains? And also, maybe we can touch on how do or can multiple eBPF applications work together?
Yeah, these are both, I think, very interesting, exciting questions. I think one of the things that really excites me about eBPF right now is the technology's been around for almost 10 years now, but we're still pushing the kind of boundary and the edge of what it can do every day. There's a lot of eBPF developers at Isovalent, and I know they're continually updating what is possible with eBPF. Then in terms of considerations that observability teams should make, I think this is actually really your classic buy versus build decision that you're going to make on a lot of your software products. And should I choose a technology that's going to work out of the box that has eBPF inside, or should I write my own eBPF programs? And the way that I think companies should kind of look at this is that eBPF is really Linux kernel technology. So if you have your own kernel team, then I would consider building your own eBPF products. If you don't have your own kernel team, I might advise against it, because essentially that's what you're trying to do with eBPF, is reprogram how the kernel works. And so whether you have that expertise in-house or you don't is up to you. But you should really, I think, take that into consideration. And then I guess the other aspect of that is I think we're going to see more and more people choosing to buy eBPF powered products because of the benefits that it brings. It's not specifically because of the technology, right? Technology is just a technology. There's a lot of ways to solve the same, issue or problem. Why people are going to choose eBPF powered products is because it provides, really that 10x increase in what you're able to do. So we've seen 10 or 100 times faster networking. You can have this complete observability at 10x lower overhead. You can provide much better tracing. You can track every single security event in a way that you couldn't before, and mitigate other bugs like DDoSing security systems, right? And so people are going to choose products based on these benefits because it solves their actual pain point. It's not going to be eBPF specifically that they're going to do it, but the benefits that eBPF provides. And so I guess that's kind of the buy versus build part. In the other part, if I'm buying multiple eBPF based products, say I'm buying groundcover and Isovalent together, what should I consider? And this goes into how eBPF programs work together. So eBPF works based on hook points within the kernel. And like the big question is like, are these programs hooking on to the exact same like points, right? And so if you have one program focused on application perform like APM, right, that's probably going to be a different hook point than a program that's doing like file integrity monitoring, right? And so they're actually going to work together perfectly fine because they aren't going on the same hook points. They're not trying to go across that, right? When you're going to have to look at it a bit closer is when you have two products that are doing like very similar things, right? So if you have two eBPF based like APM solutions, right, that might be something you want to consider, or two eBPF based security solutions, then you might want to look at what exactly they're doing so you understand the interaction between those two eBPF based products, because that's when you're going to need to consider these interactions some more.
Yeah, I think that we're looking into it right now. Like people will have a choice to choose where to go into eBPF or not. I think that we already passed this point. I mean, it's running under the hood in AWS, right? We have nothing to do. So it's running on your machines right now. It's going to be running in your security sensors, and it's going to be running in your observability sensors in a second. And basically, it's going to be all over. So I'm not sure that people will actually make an aware decision to go into that. I think that you should be aware that the industry is rapidly moving there as a main technology that is currently being adopted by cloud providers, by major players in the industry that will eventually be serving services based on eBPF all across you in your cloud environments and in other aspects. I think that it also correlates with the fact that people might ask themselves or consider, can I run eBPF right now? I think that in most cases, that's also going to be easy for you, because if you are working in stuff like Kubernetes or other environments, then the cloud provider usually would already make sure that you have the newest kernel versions without even thinking about it. So you get all these eBPF features right now without you even knowing. On-prem environments and kind of more legacy environments would probably have to consider using eBPF a bit differently. Is it the right time to upgrade a kernel version to enjoy all these options, right? Is it the right time to change the infrastructure to enable eBPF-based applications? But everybody that's on the edge of Kubernetes cloud and whatever is going on there, you're practically enjoying it right now, even if you haven't made a choice. And I think that perhaps that's the best thing we can say, because I think that the industry has already chosen, in a sense, to move in this direction heavily, and it's a good sign of this technology providing a lot of value to a lot of people.
Great. So you know what? Let's continue this train of thought a little bit and talk about the future and what you foresee for this. And as we get close to wrapping this session up, I do want to hear what each of you think will be the future of eBPF, specifically in the observability landscape, and also if there are any developments or trends that everybody that's listening to us should be aware of, or that you're excited about. Maybe we continue with you, Shahar.
Yeah, so I mean, to continue this line, I think that eBPF is definitely going to be in a lot of different segments of the services we use in the cloud. But I think that perhaps we at some point, the question you just asked, Bill, is going to bother a lot of people from a lot of reasons. So at some point, we're going to ask ourselves, why should I run like 3 different sensors to collect this data? Isn't it the same technology? It's running in the same kernel. So I think I think that at some point we will get into the point of, does it make sense to just pick and choose off the shelf eBPF programs that do separate things? And I think that eBPF will definitely move into a place of consolidation, just because it's so powerful that it can do that. It's very technology agnostic and technology stack agnostic. So basically, we will get into a point where it will make sense for more and more verticals to kind of merge in using eBPF. That's one thing, and also it will have to integrate better with other parts of the technology domain. So I think in observability, providing a clear transition between hard work that people already do in OpenTelemetry, for example, to value that they can get with eBPF, and making sure you tie this all very nice for them. This is something that is very important. Kind of assuming that eBPF can solve all the problems of the world that's clearly not the case. This is a generic approach to, for example, observability in the case we're talking about. It's not going to be as intimate as you punching in a custom metric or making sure you want to measure a specific function duration inside your code. So kind of merging these two approaches from what developers are willing to do and what you can provide them out of the box with eBPF, that is something that I think the future of eBPF really soon is going to be around that, around kind of making the most of it.
Anything on your end, Bill?
Yeah, for me, the most exciting thing about eBPF for observability is I think one thing we've talked about a lot is eBPF provides better data, right? But nobody's trying to get more data, or even better data doesn't provide that much benefit to teams. What observability teams, application teams, what companies really want is better insights. And so what I think is going to be the most important kind of evolution in the eBPF for observability landscape is transitioning from the story about better data to better insights. And I think this is where you're going to find a lot of value through either homegrown solutions, where you're picking exactly the data that you need, or a project or a product that's going to take that data and transform it into better insights for you. And so I think we're really seeing this transition from a kernel technology towards actual products and projects that solve actual business needs, right? Going from I can get better data to I can get better insights about how my business is functioning. I think that's what's going to be really exciting for eBPF in the next couple of years.
Perfect. So I think on that positive note, I think we can get close to wrapping this up. I see there's no additional questions in the Q&A. If there are, now is the time. But I just, as I'm not seeing anybody typing, I do want to thank everybody for being on tonight. I want to thank Bill for being a guest on our masterclass. Really, really appreciate it. And I want to thank both of you. It's been super insightful. It's always great and a pleasure to hear both of you speak. If anybody else has any follow-up questions that you didn't have time to type in, you can reach out to us. All three of us are on LinkedIn and other platforms, so feel free to do that. We have masterclasses once every 2 weeks. We look forward to the next one, and we really hope to see everybody on the next one as well. So once again, thank you all very, very much for being here. See you later.
Thank you.
Thank you.